Good afternoon. Welcome to our Manufacturing Month virtual plant tour hosted by Florida Makes, MACF, and Access Manufacturing Systems. We're very excited that you could join us for this Manufacturing Month tour. As you know, Manufacturing Month in Florida is celebrated all October long. What we do in October is try to promote careers in manufacturing. One of the ways we do this is through our virtual tours. This year, obviously, because of COVID, instead of our face-to-face tours, we've gone online. But what a great opportunity to share careers in manufacturing with even more students than before. A couple housekeeping notes. All of you who are on this session are muted and don't have access to webcam. The way that we will communicate with you is through our Q&A box. We'll hold questions until the end of the presentation. But what you can do is the Q&A box that you see on your screen. Please type in your name, what school you're joining us from, and your grade, and then we will get to your question at the end of our program. Today's virtual tour is being hosted by Access Manufacturing Systems. Access Manufacturing Systems is the largest CamWorks reseller in the world. For more than 20 years, Access has delivered best-in-class manufacturing software and accessories, along with unsurpassed industry expertise to hundreds of Florida manufacturers and thousands of companies across the nation. They believe that exceptional products and stellar service go hand in hand. Their extensive industry knowledge has allowed customers to enhance their machining operations by reducing setup time, doubling machine capacity, and improving overall quality. I'm going to now turn the presentation over to Joe, who's going to explain a little bit more about what Access Manufacturing does, the software that they work with, and what career opportunities there are with Access Manufacturing Systems. Now, Joe, I turn it over to you.
Thank you very much, Kristen. I appreciate that. And thank you all for joining us this afternoon. We certainly appreciate getting a chance to talk to the schools and the technical institutions in Central Florida. What we're going to talk about today is not so much software, but hardware. We provide, if we can see that first slide. Thank you. We provide not only software for the CNC industry, but we're going to talk to you today about hardware for additive manufacturing or 3D printing. In Florida, we've been in business for over 20 years, 30 years on the East Coast, serving the manufacturing industry. The company that we're going to be talking a little bit about today is called Markforged. We provide their line of 3D printers. They were established back in 2013. They do over $130 million in revenue. The cool thing is we talk about made in America and things of that nature. Well, their manufacturing is done right in Massachusetts, just outside of Boston, both their materials and their hardware. And then lastly, as a company, Access and Markforged also provide the ability to get technical support from certified applications engineers that all come from the industry. And just as kind of a side note, when we talk about careers in manufacturing, sometimes we always think about careers, and what's talked about is careers in the manufacturing plant or in the machining environment in the shop. And those are great careers. I've got hundreds and hundreds of customers here in Florida that are fantastic shops and fantastic people to work for. But there's a whole nother side of industry, and that's what we do on the reseller side. And that's applications engineering and folks that go out and do the demos of the software or do the training of the hardware and the printers and things of that nature. So it's a whole nother avenue in the career. But in order for you to learn how to do the application side of things, you first have to kind of learn the grassroots shop environment first. But that's just a stepping stone right into a career like what we do at Access. Next slide. So the first part of our journey is with Markforged is on a small printer called the Mark II. The Mark II is the top of the line of the desktop series. So what you're going to see in this quick little PowerPoint, and then we'll get into the actual video tour of our showroom, is there's three aspects to Mark Forge. There's the desktop series, which are perfect for school environments, and the Mark II is the top of the line of that level. There's the industrial, and then there's the metal. And right now we're talking about Mark II, which is the top of the line for the desktop. It's very high-strength printing. It's reinforcing your parts with composite fiber. What's really neat about Mark Forged is they actually have created not only the ability to have chopped carbon fiber, which is a very, very strong material that is merged with their nylon to create onyx, which is their material for their printers. But they also have reinforced carbon fiber strands that actually are wrapped around in the process to make your part that much stronger than just the chopped carbon fiber that's merged together. The Mark II can also print fiberglass. Yes, I mean fiberglass. And also Kevlar, which you might be familiar from vests and jackets in law enforcement, you know, the Kevlar vests. Next slide. There we go. So the next printer we're going to talk about is the X7. This is now in the industrial line of printers, and this is the top of the line of industrial. So this is designed for production houses. This is designed for, you know, folks that are doing more of a production, heavier volume, if you will, of printing than with maybe the desktop models. What's nice about a printer like this, as you can see the photo, is pick-and-place robots are very, very popular with 3D printing. You can print the pick-and-place portion of the robot to actually have that strength when it goes to pick up different parts and put them into place for assembly or for manufacturing. The X7 can actually replace machined aluminum in some cases, you know, and what we like to talk about with 3D printing is we're not looking to replace CNC machining. We're actually looking to complement it. So in some cases where you'd want to pull the job off of a CNC, you could put it on a 3D printer, especially if it's lower production type work. But in this case with the X7, it can actually replace machined aluminum with parts right off of the industrial printer, printed with the onyx material that I referred to earlier, but reinforced with the carbon fiber or fiberglass or the Kevlar. And I'll go over the materials here in the next couple of slides. These parts come right off of the printer and they're work capable, they're work ready. In some cases, they're even stronger than 6061 aluminum, and they're 40% lighter. So you've got a much more versatile capability with parts like this than you would sometimes with something that comes off of a machine tool. A nice capability for these parts are for manufacturing equipment, like creating soft jaws or any type of tooling, or even end-use parts as well. So it's a really nice fit to complement the machine tool capabilities. Next slide, please. All right. So let's talk a little bit about metal. This is the real exciting part of 3D printing. The other stuff is cool, and you're going to see some parts that we've printed, but when you talk about metal and you talk about printing, that's what really can get people excited. So the first thing about our Metal X system is it's the metal powder is bound in plastic, printed in a layer at a time, and it's shaped into your part. The parts are scaled up to to compensate for any type of shrinkage in the parts during the actual oven or sintering part of the process. Because there is a 3-step process with metal printing. There's the print, which is actually printing your part. Then there's step 2, which is a wash. And I have a nice display to show you of what the 3 actually look like. The wash is when you take that organic or green part off of the printer and you put it into the wash unit. And it looks like a big fryer, or you open up the basket and you throw your potatoes in to make French fries. This one, actually, you put these parts in to wash away all of any binding fluid or any of the plastic that's binding to the material of the part, because you want it nice and clean before it actually goes into the oven, which is the 3rd step in the process, and that is the sintering oven. So what we're doing now is we're taking these clean parts, these clean green parts, if you will, we're putting them into the Markforged furnace, and you can put several parts in there at one time. They could be different parts that will all fit, and it's actually heating and creating a binding so that way it solidifies the metal. And these parts come out almost 97 to 98% of what a standard stainless steel, if you will, part would feel like being machined. So coming off of a metal printer, they are rock solid and they are ready for end use type operations. Some of the applications that you can use on metal printing would be repairing of parts or tooling, any type of servicing that would need a replacement type part, and also prototypes. There's several manufacturing operations or machining environments where maybe they don't want to CNC the parts because maybe they only need a handful, and you want to keep the CNC for production and revenue generating. Whereas the Metal X system or metal printing is ideal for a 1-off, 2-off, 10-off of replacement parts or prototypes. Like if you look at the example there, those are impeller blades printed in the metal process that can be used as prototypes. So it's just a nice way to be able to utilize the strength of metal without tying up your CNC production type machines. Next slide. All right, so let's talk a little bit about the materials that are used for each one of these machines. So let's first talk about onyx. Onyx is the nylon mixed with the chopped carbon fiber, and that is the base material for all of the Markforged machines, other than metal, of course, of the composite machines. So it's their onyx material. Now, what's really neat is you can also, on some of their machines, just print nylon. If you just need something done in a nylon material, you absolutely can just print in nylon. But when you're looking for a little bit of strength and a little bit of substance to your part, then you'll use the onyx material. And that's the nylon mixed with chopped carbon fiber merged together during the printing process. And that offers a really nice high strength, but also an excellent heat resistance. In addition, the surface finish is really, really nice off of these machines as well. So if you need to be able to complete a project and take this part right off and you need a really nice surface finish, you can take it right off the machine with very little post-processing or any type of after the printing type work to be done with it, and take it right out to production or take it to prototyping. This material also comes in fire retardant as well. So if you've got to put it in a flame environment, it's also fire retardant. So that is the onyx, which again is the nylon material merged together with the chopped carbon fiber. The next material that Markforged has is high strength, high temperature, which is what the HSHT stands for, high strength, high temperature fiberglass. And this allows for high impact resistance, heat deflection temperatures, and it offers the highest heat deflection of all of the various continuous fibers from the fiberglass on down. So it's really nice, again, in a hot environment. That's a great material fiber to be able to use. And again, when I say fiber is what is in addition to the onyx material. So this allows your part to then become much more heat deflective or impact resistance. That's what that specific fiber is intended to do. Then you've got the third material, which is your standard fiberglass. It's very inexpensive. It's 11 times stiffer than your ABS type material, which some of you may be familiar with in your classes that are involved in 3D printing and additive manufacturing right now, or additive printing. Fiberglass is also a really nice entry-level fiber for 3D printing. So if you need just a little bit extra strength, we have one of our desktop models called the Onyx Pro, has the benefit of the onyx material for chopped carbon, but it also provides the fiberglass for a little extra strength that you might need depending upon the parts that you're printing. The fourth one on the list is our flagship fiber material, if you will, and that is the carbon fiber. So you've got the chopped carbon fiber, which comes with the nylon for the base onyx. Then you've got an even stiffer, stronger carbon fiber that is strands that are merged with the other material to create a really high strength to weight ratio. So this is the type of fiber that you would need maybe in a machining environment. Maybe you're holding your parts on a CNC machine and you don't want to make the soft jaws or any of the fixtures on the metal machine. You can actually make them on the printer and use them to hold the part for machining. So that's our stiffest and strongest fiber is the carbon fiber. Then you've got Kevlar, which is a tough, lightweight material. You can bend it. It'll bend further than any of the other fibers. It's ideal for 3D printing, especially if you need some bend in a material. Like one of the parts that we have that I'll show you was a replica of a space clamp that was used at the space station. And it has a bendable material for one part of the clamp, and it has the carbon fiber for the strength of the other, so that way they snap together and hold whatever it is that they need to snap. And this is a replica, if you will, of what was on the space station. And then lastly, on the metal side, we've got Inconel 625, we've got H13 tool steel, D2 tool steel, A2 tool steel. I know some of those numbers may not mean a whole lot to you. It's tool steel. It's steel. That's all you got to really remember. 17.4 stainless steel. And then, yes, we also can print copper. And then again, the diversity of the materials, especially for metal, is what really makes Markforged shine in the manufacturing world, because depending upon the strength of your part will determine whether or not you need the A2 or the D2, or you need the H13 or you need Inconel, or maybe you don't need strength but you need something more from a conductive capability. You have the copper. So you've got a really nice range of capabilities when it comes to metal 3D printing. And then what we've got in the development stage are another steel, but we also have titanium as well on the horizon. I can't wait to see that one, to be able to actually print titanium, but that might be a little ways out. So let's go to the next slide, which will talk about the software that comes with the printers. You're probably wondering, okay, well, this is kind of cool, and we're going to see some parts and everything, but how the heck do they even get printed, right? So one of the things that you need is a good software to go with the printers. So the process of utilizing the software is you start with a really nice CAD model. You save it as a certain file type, and then you bring it into our Eiger software. And this Eiger software is specific to Markforged. And what it does is it allows you to select the different fiber reinforcements. If you remember on the previous page, you had all those materials, right? So you actually can go in with this software and you can tell the printer, you select which printer, then you go in and select which fiber reinforcement or which material and how much of it you're going to need. And that will let you know if I need less, more, and that's another really nice aspect to additive or 3D printing technology, is that's something you really can't do on a CNC machine. You know, you really don't want to stop a job halfway through on a CNC machine and say, well, you know, we should have really used this steel instead of that steel or used this instead of that. Whereas with a 3D printer, before it goes to a CNC machine for production, you can actually do that right here with the software. You can tell the Eiger software how much fiber reinforcement you want. You can also tell it how much of a fine finish you want. You can also place, as you can see on the screen, multiple parts. So you actually can create an assembly, if you will, on the table to be able to put multiple parts on there. So it's a really nice, easy to use software that gives you a lot of control as a soon-to-be engineer as to how you want to set up the printing for this specific job that you have. And it's also cloud-based, comes with the printer that you choose. And what's really neat in looking at the software, I just got a note that says, Joe, I think we lost you.
Joe, I can still hear you if you want to keep going.
Okay, so can you see the screen and everything?
Yeah, I can still see everything. So
okay, so we should still be good.
Yeah.
Okay,
yeah, go ahead.
Okay, all right. So so in terms of the, and apologies for that little delay there. In terms of the software, another really nice feature is the fact that from anywhere you can actually access your printer. So you can actually, from home, you can go on to the Eiger software and you can select your print jobs. It'll actually monitor the job that you're printing, and then it will actually go back and you can track the progress of the job that you're printing. So it's a really, really nice cloud-based software that, especially in today's day and age with everyone working remotely or occasionally in the office or shop or at home, it's a really nice user-friendly software where you absolutely can control your print jobs remotely. So that's a little bit about the software, a little bit about the material and the machines. Why don't we actually go into the virtual tour? And let's go ahead and click on the video so I can walk you through step by step each one of the machines. We are now ready to go to the video. All right, I believe I just actually started the video, so hopefully you can see it. So this first part of the video is our metal printing. You've got the metal printer, you've got the wash unit in the middle, and you've got the sintering oven to the far right. Oops. That actually went a little fast. So you've got the printer, you've got the wash unit, and you've got the sintering. So you take it from printer to wash, out of the wash unit in the middle, into the sintering oven, and then after maybe 2 days or so, you now come out with a finished part. And I've got parts that I'll show you later in the video. This is the X7 that we talked about. This is the top of the line of the desktop, or of the industrial, excuse me. And as you can see, this is the actual print process. We're printing a sample part for a potential customer. You can see underneath the table, that's where the filament is that we talked about, the various fibers, as well as the various material. So it's actually printing one portion of the part. The other part is already just about completed. So you can put multiple parts on there. And then it's got a nice display screen. So that's where you can actually remotely, as well as in your shop, control what's going on with the printer. And that's where it's giving you all of the progress in terms of your print job. Next thing we're going to focus on are some of the parts. So there's a good example of what we call a robotic gripper. That is right off of the 3D printer with the various materials. You see Kevlar and fiberglass and carbon fiber reinforced. As you can see, this is what we were talking about with the resolution. There are your soft jaws right off of the printer that you can use in manufacturing. There's the clamp I was talking about, the space clamp. And then there's a metal right off of the metal printer in 17 stainless. And what's really neat about this ball joint, take a good look. You can see the threads that were actually printed. They didn't need to be machined afterwards. And then here's a big brother of that part done on the composite printer. Again, the threads are printed. Here's some good example of some different parts that were printed as well, a gear, a hose nozzle. And then this printer here is the top of the line of the desktop printers. So that's the Mark II, the X7, and then there is the metal setup in the back. And we even showed you the venting at the top, so that way you can get an idea of what happens in your shop, what you need to do. So that's just a little bit about our Mark Forged printer line and our software, as well as the metal. So now that we've got about 20 minutes left, we'll be more than happy to take some questions. And anything at all that you've got. If it's really, really technical and I can't answer it, I'll try to find an expert. If it's career-minded, please ask. I've been in the business over 20 years, so I can certainly try to answer any questions in regards to that.
All right, thank you, Joe. Yes, like he said, we're going to go ahead and turn it over for some questions. Please feel free to type your Q&A into the question box on your screen. Those questions will be sent directly to us, and if you want to share your name, the school you're joining us from, what grade you're in, we can answer all those questions for you. And while we're waiting for those questions to start coming in, Joe, what's the largest item that you've ever printed on one of your machines?
Oh my gosh, that's a really good question. These printers aren't designed for real large prints. They're designed for multiple prints. If you pull up one of the slides, I can actually give you the dimensions on each printer. It's up to you. But, you're talking, 12 by 10 by, 8 in some cases. but they're really designed for multiple, being able to have multiple parts, on there. But I mean, if you can fill that table and you've got enough Z height up and down, north and south, if you will, then you can print it.
Thank you. Next question. What are some of the career pathways that you or some of your engineers within your company have taken?
Good question. So my standpoint, I actually came in from the sales side, but in terms of all of our applications engineers, they all went to tech schools, apprenticeships. They all maybe have gone to high schools that have a manufacturing or machining program. And then from there, they've all gone into manufacturing industry through different shops or a manufacturing plant or a manufacturing facility. So they've all had to go through, the beginnings, if you will, of this industry. And then from there, once they've learned the trade, the sky's the limit. You can then look at companies like ours that may be looking for applications engineers. And an application engineer is someone that's got all different aspects of machining and manufacturing capabilities and experience. They've learned CAD, they've learned computer-aided manufacturing, but they've also learned real world on the machine itself. And once you get that valuable knowledge, the sky's the limit. It really is. You could then move into various applications, positions in all different aspects: aerospace, automotive, furniture, industrial, job shops that print or manufacture a little bit of everything.
Fantastic. And we're in a minute about some of our local.
Looks like we have a question.
There's another question that came in. Yes. Are 3D printers used in engineering?
Yes, absolutely. Absolutely. Small, medium, and large printers. What happens is when you're looking at engineering, that's a great question. An engineering house or an engineering company may not do manufacturing in-house. So they may have 5, 6, 7, 10 CAD engineers that are really good at SolidWorks or Autodesk or any one of the real popular solid modeling packages. And they're all designing and coming up with ideas, the next big product, or maybe a manufacturing company comes to them and says, hey, can you help us design this new whatever? And one of the things that they like to do is after they've drawn up the part in their modeling system is they'd like to be able to take it to real world. So they'll print it. So maybe they've got an idea of a new sole of a shoe for Nike, or maybe they've got an idea of a new apparatus for a garden hose, right? The nozzle that goes on the garden hose. Or maybe it's a new part for a lighting fixture for a company that builds outdoor and indoor lights. So they'll use the 3D printing in their engineering company to be able to create what's called a prototype. And then they can take that prototype to their customer and say, here, this is what we think it's going to look like. So absolutely, 3D printing is used in engineering, architecture. It's used in the construction field. We actually have a customer, believe it or not, that builds swimming pools. And they bought one of our small desktop models so that they can do two things. One, on a small scale, they can show someone what the pool is going to look like, not in a drawing, but actually in a real product. And two, they created little giveaways. So if somebody decided to buy a pool from them, they gave them a little giveaway of what their pool actually looks like on a keychain. So it's really versatile what you can do with 3D printing and engineering.
Thank you. I have another question. You mentioned that shortly you'll be able to print titanium on some of these printers. What are some applications that you foresee for using the titanium?
I would say aerospace would probably be a big one. I'm not sure if general manufacturing would be using, the titanium, but possibly defense would probably be using titanium. So there's a host of things. Even the materials that we have now currently, the metal is being used. Some of the potential customers that we're looking at using metal are in Army bases, Navy bases, especially in certain areas where they need to make a repair quickly and can't wait 3 or 4 weeks for something to be backlogged. They'll go ahead and print what needs to be printed in just a couple, 3 days, and they've got their replacement part.
Thank you. All right, I'll go ahead and remind you all that we want to ask as many questions as you can, so please feel free to type in those questions that you may have about access manufacturing or 3D printing in the Q&A box. While waiting for those questions to come in, I'd like to thank some of the technical colleges who are here on our call today. We have representatives from Orange Technical College. Their Mid-Florida campus has manufacturing programs right off of Oak Ridge and John Young Parkway. We also have Lake Technical College joining us today. Lake Technical College is in Eustis and not a far drive from anywhere in Orange County where some of our schools are joining us from today. And then we also have Valencia College with their manufacturing programs in Osceola County and in downtown Orlando. And these are great programs to check out. If anything that Joe is talking about today, if you're looking at possibly moving up into a career in 3D printing or engineering, or some of the software that goes along with it, as he mentioned, a lot of the programs that you want to get into are these skilled trade programs such as machining, CNC, welding. These are all great programs to learn, and all these programs are offered at these technical colleges here.
And we have another question.
We do. It seems that Kevlar had military applications. Do you work with law enforcement or military?
The answer is yes. We have several manufacturers that actually have contracts with law enforcement agencies as well as military establishments as well. The military uses mark forged printers on a regular basis, not only to print Kevlar, which is a very popular and very useful material for that type of operation, but also all of the other materials as well, especially if they need strength. I don't know if you'd heard this, but a military installation actually used a 3D printer to build a bridge when they were out in the field, so they could actually cross over a creek. So the 3D printers, and especially the way that they are manufactured, that X7, if you remember the big one that wasn't metal, actually can come apart. So you can actually take it, you could put it in the back of a vehicle, and you can actually drive it, so it becomes portable. So military installations, bases, and things of that nature absolutely can take that on the road with them when they need to be able to print certain things that they might need either in the field or on the base or wherever they need it. But law enforcement, definitely for sure. There's several manufacturing companies and various machining organizations that have 3D printing in it that have contracts with the various agencies. Good question.
Joe, it seems to me that there may be opportunities within this field for travel, especially if you're working in defense, aerospace, in those types of industries. What type of travel opportunities have you seen with this industry?
Well, in manufacturing in general, obviously pre-COVID and hopefully soon post-COVID, we'll definitely get back to travel. Not only is it travel from a standpoint of going on site to make sure that the prototype that you created works well in the environment that you're manufacturing it for, but also on our side, the many trade shows. There's a large trade show every 2 years in Chicago that unfortunately was canceled called IMTS, and they have an entire area designated for additive manufacturing and 3D printing. So absolutely, between applications and between manufacturing, there is quite a bit of travel available in this type of industry.
Okay, well, we'll go ahead and give one last call for some questions if there's anybody else who have questions. In the meantime, Joe, if anybody's interested to learn more about Access Manufacturing and about 3D printing and the types of machines and printers that you use, where can they find you?
They can find us at accessmfgsys.com. That's SamYellowSam.com. accessmfgsys.com. Or you can call me directly. I'm the national sales manager for the company, and I'll make sure I get you in touch with the right people. I'm at 407-895-7057, and my direct extension is 9420. And it looks like there's one last question in regards to printing homes and buildings and even food. Do you foresee printing going that route with some sustainability, or do you see it staying more mechanical? Well, that's a good question. You know, I think it's going to stay more mechanical, industrial, but certainly, you know, the technology is so fluid and it's constantly changing that I never would have dreamed to see metal 10 years ago. You know, if somebody was to tell me that they could print a stainless steel part that's as strong as something that's coming off of a shelf in a shop, I would have said, come on, you know, but it is. We're printing metal. We've printed cars. At the trade show that I mentioned not long ago, 2 or 4 years ago, they printed a car off of one of the very large format printers. So is this type of printing homes and buildings and things of that nature going to be around? Yeah, I think it's going to be around. But I think the vast majority, at least in the short term, is going to be things like industrial, mechanical, those type of product lines.
Okay, thank you. Well, I know that this class period will probably be ending soon, so we'll go ahead and wrap up this session. We'd like to thank Access Manufacturing and Joe one last time for his time today and explaining all the new and exciting features and things that are happening in the world of 3D printing and in manufacturing. Once again, the whole purpose of these virtual tours are to open your eyes to the possible careers and future opportunities for you in the manufacturing industry. Throughout the month, MACF and Florida Makes will be hosting virtual tours similar to this, and we will send out the link to all those tours so you can view this one as well as other ones throughout the month, all throughout the Central Florida region and the state of Florida. So you can find out about the different types of manufacturing going on all over the state and all the different career opportunities there are. And we'll also link you to some of those, to some of the programs that we talked about, whether it's through Orange Technical College, Lake Technical College, or Valencia College right here in Central Florida to help jumpstart your careers in these manufacturing industries. So again, with that, I want to thank all of you from Windermere High School. We had Olympia High School, Northeast High School, Lake Technical College, and Orange County Public Schools for joining us today. And if you would like more information on Manufacturing Month or manufacturing in general, you can always go to macf.biz. That's the Manufacturers Association of Central Florida website. Again, macf.biz, and we'd be happy to connect all of you to your next career opportunity in manufacturing. Thank you very much, and everybody have a great day.
Thank you.
Thank you.